turkey, and a roasted flatbread. Cruise Buffet will offer popcorn chicken with garlic breadsticks. No activities taking place today, Wednesday, February 1st, with a 1 o'clock early release. Once again, 1 o'clock early release. Activities on Friday and Saturday, our men's team, men's basketball, will be on the road starting first Friday night with Huron. And on Saturday, they will be in Mitchell. Our women's team will host Huron on Friday night, and then they will host Mitchell on Saturday. Saturday, we have varsity wrestling at Jenkins. Musical rehearsals begin on Monday, February 6th at 3:30 in the music room. All cast should attend. Anybody interested in participating in technology or the crew for the musical should see Mrs. Meyer. Or meet in her room at 3:30 on Monday. Anyone thinking about planning some pole vault this year? Please visit with Mr. Nida. SDSU will be in the Commons during the lunch hour today. There is no GSA meeting in Mrs. Bunet's room today during lunch. Again, seniors applying for South Dakota Technical Schools. The Build to Work Scholarship is now open. You are requested to begin filling out the scholarship. Please stand for the pledge. Pledge allegiance to the flag of the United States of America.
Who needs more time? Okay. Anyone in winter activities, like any of sports? Hmm. I was just curious if they start practice right away after the early release, or if they actually make you wait until after the meetings. Okay. A lot of coaches try to get out of meetings and professional development stuff by saying, well, sorry, have practice. So they'll just keep practice right away after school so they can get out of it. So. Yeah. I was just curious. Okay. We've got 3 known commandments of domain. I suppose technically there is another one that's absolute value, can't be negative, but it's not really a domain thing yet. It's more of a definition, but it's iffy, gray area. Which of those 3 rules is h of t potentially going to violate? Is it going to divide by 0? Is it going to have even radicals? Is it going to log a non-positive? Okay, thou shalt not divide by 0. So you take that denominator, set it equal to 0, and you get plus or minus 1 are the things that are going to break math. So if I want to exclude them, but have everyone else's okay, I've got set builder. All x's such that, no, all t's. How many of you got caught in the trap and put x's?
I did, but then I switched.
I don't care. It's fine. Okay. Unless it's specific to the formula because it stands for a particular thing, I don't care. All t's such that t does not equal plus or minus 1. And t would be an element of the reals. Saying, I got very specific rules. Don't eat my goldfish. These 2 guys always eat my goldfish. Go away. It's just those 2. If I want that as an interval, then we're going to go from negative infinity all the way to negative 1. Can't touch us. Negative 1 to 1. Can't touch us. And 1 to infinity. You put a parenthesis union on top of the thing that's not allowed. If I'm looking at f of x, I have 2 things that I might break the law for. I can't do even root of negatives, but I also can't divide by 0. So if I take that 2x minus 3 equal to 0, I got 2x is 3, x is 3 halves. So that's the dividing line between what's allowed and what's not allowed. So we ask, is 3 halves itself allowed? Can I do the square root of 0? I can do the square root of 0, but it's on denominator, so don't do that. And then, which way am I allowed to go? Left or right? Bigger or smaller? So it's an open circle, which means it'll be parenthesis off to infinity if I'm going to do interval notation, or green. Set builder notation, I would say all x is such that, and my rule is simply x is greater than 3/2. And let's get that other one over here. So, you had 4 things to find, and then naturally there could have been a little goof in there. Maybe your inequality went the wrong direction. You used brackets instead of parentheses. So we're going to say 1 for that, 1 for that, 1 for that, 1 for that, 1 for oops. Like I did all of that stuff. Everything looks golden. I put a bracket here. Oops. That little floating, I made this little mistake. I put greater than or equal to on my inequality, but I put the parenthesis on the interval thing. Okay, 1 off. 4 out of 5. Most days you should be sitting at 4 out of 5, 5 out of 5. If you get a 3 out of 5, either there was a misconception that going through things allows you to click into place and you're like, oh, okay, I'm good. Or you got to ask questions because something is not clicking. Okay? This isn't about playing the points game. This isn't about trying to wiggle your way into a particular percentage. This is your gut check. If it is honestly a 3 out of 5, 2 out of 5, you need to be asking questions. Come in early. Come in 10 minutes early. Go through a few problems with me. Come back after school, Spartan time. If you can stand the nerd herd, come in here during lunch. I got more kids in here during lunch than all of my classes. We have in here yesterday like 29. Like the nerd herd piles in. The assignment. And there was a couple of problems. You okay there, bud?
Where's the bucket? Oh, it's there. Uh-oh.
You know, normally when you say it's right in front of your face, like it's a turn of phrase, but
Really?
it was legitimately in front of your head. Like, you're killing me, Smalls. The assignment part. For those that are actually doing stuff the way they're supposed to, are you still checking the solutions? You got the solutions in our shared Google Drive folder. If you got questions, ask. I want the solutions there because I want you to be able to look at, oh, this is the final product. This is how they got there. That way, you can usually reverse engineer things if you need to. But if you got a question on stuff, it's as simple as just take a picture of your work, send it to me and say, I'm not sure where to go from here. Or you say, why is this supposed to be negative? I don't get it. Just a little question of clarification. I'll get kids who say, well, I don't want to ask you questions. Y'all, we all live on our phones anyway. I don't care. First thing I do when baby bear's getting me up at like 4:30 in the morning after he stops screaming is I'm going to check notifications. I'll answer you. You ask me a question at midnight. Okay, I'll answer you at 5. Make sure your stuff is silent too. But you got a tutor in a pocket. Okay, use it. All right, we did not do this, and I was right. I was right. We were a couple of minutes off, and first hour barely finished the one right before this. So there you go. I want to see if you can do it on your own. Good thing it's on the page in front of you. Oh, God. Yeah. Slow down. Brake early. Don't slam on the brakes. Exactly like we left off yesterday. Start by estimating. You have to be able to read a graph. What do the axes mean? Don't go straight to what is the question. Maybe read the problem before that. Okay, what does it mean? What are your X and Y axes? What's your independent and dependent variable? Input, output. The function itself, be careful. I hate when they do this in textbooks. The equation continues on the next line. So when you are checking these algebraically, note that there are 3 more terms. Okay, let's see if you can do it. They ask you a question. What is value of stock on this day? Those sound like 2 different aspects of a graph, input, output, value and stock, or value and day. So finger trace it, get your estimate. Then use that function just like we did yesterday to make sure that your estimate is correct. You may have multiple answers to some of these questions.
Oh, plus 31.
Note that like the one yesterday, it's got an inequality attached to the function. And that's because these polynomial models often fit really well with interpolation, meaning inside my data, they're great. But once I go past my data, in this case, past 20 days, the model doesn't make much sense. So they're just restricting the model. Boy, we got worried. Well, when we hear a couple of kids talking bad about themselves and calling their friends dumb, we might have to go get the dinosaur and do some whacking. So,
when we plug it in back, we put like 30 for Y.
correct.
So, because it says
Yep.
$30, so you do 30, and then you go back to
The graph. Okay, now you're not going to see too much because your window does not match this window.
Yeah.
So make the windows match.
I will do that once I can, once it's done loading.
Yep. Oh, if y'all don't know this part, on the TI-84s, you know how you get that little yellow circle up in the corner? It's thinking. Leave it alone. It would be really annoying if in the middle of a test while you were thinking, I came over here and kept poking you and poking you and poking you and poking you and poking you. Said, think faster. It doesn't work that way. Just let it do its thing.
So for this one, would this be like a half a day then?
So it would be on the first day, like
Okay.
on day 0.
Okay.
Yeah. Well, day 0, so it's on the day that you start, because it starts at 31 and then goes down. Okay. Note that there are 3 different points at which we hit that 30 days. When you calculate your intersection, you have to put Blinky next to that intersection to find the one closest to where you put that blinking cursor. Okay. I'm sure everyone got day 10, 32. Like, if I think it's like actually 32, not even rounded, just 32 plain. Okay. So, easy peasy. If I want this on my calculatron, ooh, big. I type in the function y equals, blah, blah, blah. And if I want this exact graph, I'm going to change my window to match this exact window. I can make my x's go from 0 to 20, going by 2's. Hey. Frank's running a little slow today. My y's can go from 0 to, looks like 42, going by 6. Do you remember yesterday I had showed you how to get those grid lines on there? If that helps you, you don't need it. But under Format, right above Zoom, I can turn grid lines on. And now my graph should be exactly what I saw on my paper. Yee. If I want when my stock share was $30, that is my output. My Y value, I can either set this equal to Y value, everything to one side, now it equals 0, solve. Solve the polynomial. Or, if I don't want to go through all of that headache, I go to Y equals and say, I want to know when this equals 30. 30. Thank you. And you see it crosses that graph 3 times, so you find the 3 intersections. I'm going to move Blinky around, and I want you to watch what's happening here. If I do calculate my intersection, okay, look at where the cursor is now. Let's say it was back here a little bit. And then I go in the second curve. Okay. Which intersection do you think it's going to find? Okay. It's not going to find all 3 of them for me. It's going to find the average distance between them, what is the closest to the cursors that I put on there. So if you ever have multiple of these, you're going to have to do it multiple times, and just make sure Blinky is close to the thing you're trying to find. Okay? So this one, I say it's on day 15. This was clearly on that initial day, day 0. Like I haven't even hit the end of day 0. So you'd say on the first day, right? It has not yet been 1 day. It's on the first day. This one, what was that? About day 9-ish, okay? And if you wanted to get more specific, you're cool with that? Like, if it's 15 and change, subtract 15, take that decimal times what? If I want to know when on the 15th day, take it times 24 hours. I'd get the hour, get rid of the whole portion, take that times 60 for the minutes. You can get super specific with this with unit analysis. Okay, just making sure we remembered that. Okay, domain and range from a graph. I don't even know what the function is, but I can find its domain and range by just asking where it exists. So remember that domain is the x-axis, or my independent variable, my input. So if I want to know what my domain is, I'm going to press this X button. And you just, almost like the vertical line test, you just go left to right across the graph and ask, does it exist? So back here at -10, does it exist? Not yet. And then at -8, it exists. Parenthesis or bracket. Close circle, it can equal. Bracket at -8. That's an infinity. There we go. And I keep going until it stops existing. Lies. Because once I hit -4, I got a hole in the graph. Remember these from last year or Algebra 2? Sometimes you get a hole in the graph. Do you remember what causes that? When factors cancel, it's called removable discontinuity. That factor was canceled. It reduced down, and now -4 does not exist. See that open circle though? It exists all the way up to here. It exists all the way up to here. So at -4.0000001, it exists. At -3.99999, it exists. So I need a parenthesis, can't touch this, -4, and then go. I have to exclude this specific point. And then I say, you get out of here, you get out of here, go away. Does it exist? It exists, it exists, it exists, it exists, it exists. When does it stop existing? Never! Because that arrow goes off to the right forever. So I put infinity parenthesis. Okay? There's my domain. So what am I going to do for range? I'm going to go the other way. My range is usually my y's. It is the dependent variable. It is the output. And I'm going to make a horizontal line at y equals number. And I just ask, when does it exist? Incorrect. Watch the scale, right? -10. Each box is going by 2. Okay. Open or close? So parenthesis or bracket. Yeah. So we got -10 to, and I go up and up and up and up and up. What happens here when it's like hitting it a bunch of times? It exists. And I keep going up and up and up, and it exists, it exists, it exists, it exists. Uh-oh, there's a hole. Why? It exists over here. So it still counts. I'm just asking if it exists. Does the value y equal 4 exist somewhere in the range of this function? Even though there's a hole over here, it exists there. So it's still okay. And it goes to infinity and beyond. So it's just negative 10 to infinity. That's it. A couple notes about these kind of graphs. We can't be hyper specific and sure about a thing, right? Like, I don't know if this curve right here, where is that? I know it's near negative 7. Do I know for sure? Certain? For sure, for certain. New word. It's like a new Baskin Robbins flavor. Do I know for certain that this is negative 7? I have to assume that it is. Because otherwise there is no way to know without the function given to us. If the function was given to us, remember, blinky here, go find your minimum, I could find exactly where it is. But if it looks like it touches a particular point, just assume that it does. Okay? So, can you find domain and range off of a graph? If I've got open and closed circles there and curves, or if like 2b, it's a piecewise function. Remember, the question is just, does it exist? It's not how many times, it's not for how long, it's just, does it exist? If it does, it's included in your domain and range. I think the best way that I've seen kids do this visually, since you can't move a line across there, is you just get like a straight edge or something and you put it on your graph and just move it across the graph to guide it and say, does this exist or not? Oh yeah, 2B, you got to write it a certain way. And we'll see if y'all figure it out.
Oh no, I'm just confused on the first one with the domain or the range.
When does it start existing?
2, 4, negative. I don't know.
What Y value does it start existing? What's the lowest it ever goes?
Oh, 0.
Yes. What's the highest it ever goes? Okay. See a couple of scrunched eyebrows, so that tells me we've gotten to the range on 2B. Okay, first one. When does it start existing? All the way until, and I'm just going to follow this, 6. So I'd say domain is bracket on -2, parenthesis on 6. Close circle, open circle. Range. Careful. When does it start existing? Parenthesis or bracket. Even though there's a open circle here that says not 0. There's a closed circle back here. So yeah, it does exist. So my range will bracket start at 0. And this is what I mean by, am I certain that that is at 4? We have to assume that it's at 4. It could have been at 4 and 1/81st. But I've just got to assume. So I'm going to say until 4, and since it does touch that, I've got to use a bracket. Okay. Basically, unless you have a asymptote or a hole shown, you're going to assume that it actually hits the value and you're using brackets. Contestant 2. At 4, it or -4, it starts. Parenthesis or bracket. Parenthesis because of open circle. All the way until, this is sketchy. Does it exist or not at 2? Because I've got 2 graphs that go there, but both of them are open circles. So I need to go from -4 to 2, parentheses both. Can't touch this, and then 2 to where? Now, this is another reason to use these vertical and horizontal lines. I will get kids who will say from 2 to -infinity. From 2 until, when does it stop?
Infinity.
All the way to positive infinity. I know that line is going down, but you're looking at the x-axis. It keeps going to the right. So I say to infinity. Okay. Range. All right. When does it start existing? Right? That arrow goes all the way down. So the range is going to start at -infinity. And it's going to come up until -2, parenthesis or bracket. Okay. Oh, the line is there. Remember, the line is like a whole bunch of dots, a whole bunch of closed circles, if you will. So it does exist at 6, but not on either side. So how do I write that? Just 6. That's it. Nothing else. Just union 6. Don't put from 6 to 6 bracket bracket. This is brought to you by the Redundant Department of Redundancies.
Yes.
An interval shows change. This is not change. This is just a location. That's like asking, when you're sitting at the stoplight, are you accelerating or decelerating? Yeah. You're just sitting there. Like, it's not an interval. It's not any change. So don't try to write it as change. It is just the number 6. Now, every year, kids do okay with those. Hold on. There we go. I just want a blank graph. Don't go here. I just want a blank graph. Uh-huh. I'm gonna do a mishmash review here and see what y'all got. Go.
No.
No me gusta. Not happening.
Just in a random spot.
Where do we write this?
See how
badly this goes.
Go.
Is that on the very far left? Is that an arrow?
Yes.
We just write it like right here.
Yeah, it's somewhere. Off in the margin.
What's the scale going by? Just by one?
Once. Yep. I don't know. You figure it out.
But it's on the left.
Ah, argue, children.
You tell me if I got it right.
We think we got a final answer?
What are those two doing up there?
I don't like those.
Yep.
One thing at a time.
I can't even. You walked in front of me and I completely lost. We're gonna go with 10. I'm pretty sure it's 10. 10, yeah. And then it's also 10 for this. Maybe that negative 10 is supposed to be negative.
That was so cringy.
How the heck did you do that?
Do kids even do that anymore?
Only him. Only him. He dabbed. What? Yeah.
I thought that died in like 2019.
Are you gonna whip a nay now too?
Oh, I see.
Next part. I did put those. Oh my god. That did die at like 47.
Which I definitely not right, but
No.
no, I got it.
You wouldn't dare.
Yes, no.
I just feel that you just got gabbed on, Connor.
Alright, so I definitely
Yes, no. Right idea, wrong numbers.
definitely not sure if
I'll do the
Wait a minute. I think I'm doing this wrong. My brain can't comprehend this.
Yeah?
Everything in there is.
Nailed it.
Wait, hold on.
Wait, why are they doing it so quick?
Is that right? It didn't have space.
Is this like
Nope.
a lot easier than I'm thinking?
Well, okay.
Oh.
Yes, but simplify. You have a bracket here and here.
Yeah, but don't you need the space between the two?
But doesn't it equal that number? Do you need a union if it equals the number? No.
They all overlap.
It's like they may be disjointed on the graph, but it exists.
But where do you get that? Oh, it's just.
Don't you are over complicating it. Big range. She's already got domain.
What?
Answer is what?
Am I off? Am I just like?
Domain is right, range is not.
Are we supposed to? Is it this one that It's still wrong, isn't it?
All right. So some of the kids in the past have had success with kind of shading your X and Y axes, where they'd come back here and say, along the X axis, does it exist back at negative infinity? How do I know? To infinity and beyond. So I'm going to keep going until, does it exist? Yes. So I just keep going. Does it exist? Does it exist? Does it exist? Does it exist? Until I hit this. It exists because, still down here, so now I'm just going to follow this line. And it exists, it exists, it exists, all the way until I get here. Open circle. Oh wait, it exists right above that. Keep going, open circle. Now there's a gap. I don't see anything in between. And then it starts here and goes to infinity. My domain, negative infinity to 5, 7 to infinity. Parentheses on 5 and 7. Because it exists along the x-axis. It exists here, 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 here. This is irrelevant because of this line. Like, it constantly exists. Okay, the range. Oh. The range, does it exist down at negative infinity? It does. How do I know? Arrow goes down to negative infinity. So, from negative infinity, I'm just going to eyeball this one all the way up until negative 1. I'm following that graph. Then at negative 1, now I'm going to hop over here, and it keeps going. Uh-oh. Now there's a gap. But this guy goes forever. So, these two up here are actually irrelevant. Negative infinity to infinity. All real numbers. Okay. I actually messed up when I did this line. It was supposed to be both of them all real numbers. Yeah, it's usually what I do. But does the shading thing make it a little more obvious? For some, it's not going to work for everyone. But that shading along the X or Y axis, I have found some kids, that's the thing that makes it click. So do it on test. Do it on quiz. Do it on assignment. Okay? All right. So that was these guys. No. Come on. Come on. We did to this. We did to this. Here we go. Okay. Approximate y-intercepts. Y'all, I can ballpark the y-intercept just by looking at the graph, but do you remember the algebraic way to find a y-intercept? X equals 0. So I'm not even going to bother with the estimate on these. I'm going to plug a 0 in for x. My y-intercept is at 4/3. That's it. It's just y-intercept 4/3. If I want a 0, okay, now I got to do a little thinking. If I put a 0 in for x, what are those vertical lines? Absolute value. Absolute value means what? Okay. It means the value has to be positive, but what is absolute value? Distance from 0. Okay. The idea is if it's 11 miles from my house to the school, it's not negative 11 miles from the school to my house. Distance is distance. I can't say that someone is negative 5 feet tall unless I'm just insulting them. Okay. Like you can't actually be negative height, negative length, negative distance. So when I say negative 5, but absolute value is just 5. 5 minus 1 is 4. So y-intercept is fairly simple. Down below that, go find 2 more y-intercepts. Plug in a 0 for x, solve. Remember to always write it as precisely as possible. Papa Bear does not like decimals. Decimals are not accurate. In this house, we're going to write things in simplified fractions, simplified radicals, terms of pi, I, and e. Too bad. That'd be like saying you washed the dishes, but all you did was run the dishwasher, you didn't look at any of them, and now there's still food stuck on them. Okay? You're BSing the answer. Okay? Or if you, worse, if you just let the dog lick it. And then just run it under the water quick and say you're done. That's nasty. Okay? Put a 0 in for all those x's and just get 4. Be careful. If I put a 0 in for x, don't you call it 2 point something. Your y-intercept is the square root of 6. And you just leave it like that. Okay? That's the answer. So if these are y-intercepts, take a wild guess what's after that. Okay. X-intercepts, except x-intercepts got different names. Remember that the x-intercepts are when y equals 0. So they're also called zeros. They're called zeros, so when I set y equal to 0 and solve, I get them. Therefore, they're also solutions. They're also roots. Okay, so they've got a bunch of different names, but they're all talking about it in a different context. It's just like, you know, one of the kids that comes into my room, I can call them by their name, or I can say, sup, nerd. Okay, it's still the same person, but I'm talking about them in different contexts. So they are going to say find the zeros. They say approximate, I say screw that. Instead, I solve by setting equal to 0. And solve. Y'all know how to solve a quadratic. You did a quiz on it last week. Find those zeros as accurately as possible, however you're going to do it. 15 halves, 1/2, 1/4, 1/4 squared, so 5, 1/16, 1/16, 15 halves by 8 by 8, 80, 40, 120, 120, 119 fourths.
No, you won't, since there's a
How do you do that?
Well, I've been up since 4, but mental math.
No.
Right, 15 halves, 15 halves, 1/2. Half of that is 1/4. 1/4 squared is 1/16. So I need to multiply by 8. 80, 40, 120, 120. Plus 1, not -1. Literally missed the negative. So then plus or minus 11 fourths. So 10 fourths is 5 halves and -3. 5 halves and -3. Okay. Okay, so you can solve this by, oh wait, that's factorable. You can factor it. You can quadratic formula and complete the square. I did complete the square in my head and I missed a negative. Oops. So down below that, can you do the same thing? I hope you all can factor by now. You're in pre-calc. Call that 2x plus 5, x minus 3. No, it's minus 5 plus 3.
Yeah.
Okay. So I can factor it, I can quadratic formula, I can complete the square, whatever my jam is. Down below that, can you solve those by set it equal to 0? I know that that's a cubic, but what's the first stop on any factor train? Take out that GCF.
They're all the same color. Oh, no, it's fine.
3, 8, 12, 7, 5, 24. 24, -4, negative. Yeah, it is. 3, 1. Oh, hey, they are working. Okay. So, cutting off there. And you know what? I'll just let you know now. I ain't doing an assignment with today. You'll get an assignment with 1, 2 tomorrow. No. Maybe I do. Yeah, I'll do an assignment, but it's going to be really, really short. It's going to be some of those domain problems. Remember, quiz tomorrow, and you should be turning in your Chapter 0 packet. Uh-huh.